Imagine a hummingbird, wings a blur, effortlessly maintaining its position in midair. This tiny bird with its rapid wing beats seems to defy gravity, holding itself steady as if suspended by an invisible thread. The hummingbird's ability to hover is a marvel of nature, a perfect blend of speed, agility, and control. This is the essence of helicopter hovering, a captivating display of control and precision. Much like the hummingbird, a helicopter can remain stationary in the air, its rotors spinning at incredible speeds to generate the necessary lift and stability. This ability to hover is not just a technical feat, it is an art form that requires skill and practice. In the realm of aviation, hovering is far more than just staying stationary. It's the foundational skill upon which all other helicopter maneuvers are built. Whether it's flying through urban landscapes or hovering over a scenic vista, the ability to maintain a steady position in the air is crucial. It allows pilots to perform a variety of tasks with precision and confidence. Mastering the hover is the gateway to unlocking the helicopter's true potential, allowing pilots to land on pinpoint targets, perform intricate aerial tasks, and navigate challenging environments inaccessible to other aircraft. Imagine landing on a tiny helipad atop a skyscraper or maneuvering through narrow mountain passes. These feats are made possible by the art of hovering. The ability to hover grants helicopters unparalleled versatility, making them indispensable tools in various fields, from search and rescue operations to aerial photography and transportation. In a rescue mission, a helicopter can hover above a stranded hiker, lowering a rescuer to safety. In aerial photography, it can provide a stable platform for capturing stunning images from above, and in transportation, it can deliver cargo to remote locations with pinpoint accuracy. However, achieving this state of controlled equilibrium is no simple feat. It requires a deep understanding of the helicopter's mechanics and the principles of aerodynamics. Pilots must be attuned to the slightest changes in wind and weather, constantly adjusting the controls to maintain stability. It demands a delicate understanding of aerodynamic principles and a mastery of the helicopter's sensitive controls. Every movement of the joystick, every adjustment of the throttle, has a direct impact on the helicopter's position and stability. The pilot must be in tune with the machine, responding to its feedback with precision and finesse. The pilot becomes a choreographer of forces, making constant adjustments to counteract the ever-changing environment and maintain a delicate balance in the sky. It's a dance of precision and control, where every move is calculated and every decision is critical. The art of hovering is a testament to human ingenuity and the relentless pursuit of mastery in the skies. Hovering is a captivating dance with unseen forces, a constant battle against gravity, torque, and wind. The helicopter, a marvel of engineering, must maintain a delicate equilibrium to stay aloft. Each moment in a hover is a testament to the pilot's skill and the machine's precision. The interplay of aerodynamic forces and mechanical ingenuity creates a spectacle that is both mesmerizing and complex. For aspiring helicopter pilots, the journey to mastering this skill begins with grasping the core concepts that govern a helicopter's behavior in the air. Training starts on the ground, where students learn about the principles of flight, the mechanics of the helicopter, and the importance of each control. Pre-flight briefings and simulator sessions are crucial in building a solid foundation before taking to the skies. Unlike fixed-wing aircraft which rely on forward motion for lift, helicopters generate lift through the rotation of their overhead rotor blades. This fundamental difference allows helicopters to perform maneuvers that fixed-wing aircraft cannot, such as vertical takeoffs and landings, hovering, and flying in reverse. The versatility of helicopters makes them invaluable in various applications, from search and rescue missions to aerial photography. This rotation creates an area of low pressure above the blades and higher pressure below, resulting in an upward force that counteracts gravity. The precise angle and speed of the rotor blades are critical in generating the necessary lift. Pilots must understand the aerodynamics at play to effectively control the helicopter's altitude and stability. Controlling a helicopter in a hover requires a delicate touch and unwavering focus. The pilot must constantly make minute adjustments to the controls to maintain a stable hover. Even the slightest deviation can lead to instability, making hovering one of the most challenging aspects of helicopter flight. The pilot must constantly manipulate the collective, which controls the pitch of the rotor blades and thus the amount of lift. The collective lever is a critical control that directly influences the helicopter's vertical movement. By adjusting the collective, the pilot can make the helicopter ascend or descend smoothly. The cyclic, which tilts the rotor disc, dictating the direction of movement. The cyclic stick allows the pilot to control the helicopter's pitch and roll, enabling forward, backward, and lateral movement. Mastery of the cyclic is essential for precise maneuvering and navigation. The pedals, which control the tail rotor and counteract torque, the tail rotor is vital in maintaining directional control and stability. By adjusting the pedals, the pilot can manage the helicopter's yaw, preventing unwanted spinning and ensuring smooth turns, and the throttle, which manages engine power. The throttle control is crucial for maintaining the appropriate engine speed and power output. Proper throttle management ensures that the helicopter has enough power to perform various maneuvers while conserving fuel and maintaining efficiency. Every input influences the delicate balance of forces, and even the slightest overcorrection can send the helicopter veering off course. Pilots must develop a keen sense of coordination and timing to make precise adjustments. The art of hovering is a continuous learning process, requiring practice, patience, and a deep understanding of the helicopter's dynamics. Each flight is an opportunity to refine skills and achieve greater mastery over this intricate dance with unseen forces. At the heart of helicopter hovering lies a fundamental interplay between lift and thrust. Lift, as we've established, is the upward force generated by the rotating rotor blades, counteracting the downward pull of gravity. Thrust, on the other hand, is the force that propels the helicopter horizontally. In a hover, thrust is primarily directed sideways to counteract the helicopter's natural tendency to drift. To maintain a stable hover, the pilot must ensure that lift precisely balances the helicopter's weight, while thrust counteracts any sideways drift. This requires constant adjustments to the collective and cyclic controls. Increasing the collective pitch of the rotor blades generates more lift, causing the helicopter to climb. Conversely, decreasing collective pitch reduces lift, leading to a descent. Section 4. Taming the twist, the tail rotor's crucial role. One of the more intriguing aspects of helicopter aerodynamics is the phenomenon of torque. Torque is a force that causes rotation. In the context of helicopters, it is a critical factor that must be managed to ensure stable flight. As the main rotor spins in one direction to generate lift, it creates an equal and opposite force that tries to spin the helicopter's fuselage in the opposite direction. This is a direct application of Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. Think of it like what happens when you tighten a screw. The screw goes in as you turn the screwdriver, but your hand wants to move in the opposite direction. This analogy helps to visualize the counteracting forces at play. This is where the tail rotor, that smaller rotor mounted vertically on the helicopter's tail boom, comes into play. The tail rotor is essential for counteracting the torque produced by the main rotor. The tail rotor acts as a powerful fan, generating a sideways thrust that counteracts the twisting force of torque. This sideways thrust is crucial for maintaining the helicopter's stability and direction during flight. By adjusting the pitch of the tail rotor blades using the pedals, the pilot can control the amount of sideways thrust, keeping the helicopter pointed in the desired direction. This control is vital for maneuvering the helicopter, especially during takeoff, landing, and hovering. The tail rotor's role becomes even more critical during complex maneuvers and when the helicopter is hovering in place. In these situations, precise control of the tail rotor is necessary to maintain balance and prevent unwanted rotation. Regular maintenance and inspection of the tail rotor are essential to ensure its proper functioning. Any malfunction or damage to the tail rotor can compromise the helicopter's ability to counteract torque, leading to potential safety hazards. In summary, the tail rotor plays a crucial role in the safe and stable operation of a helicopter. It counteracts the torque generated by the main rotor, allowing the pilot to maintain control and direction. Understanding and managing this component is fundamental to helicopter aerodynamics and flight safety. Section 5. Fighting the drift, understanding translating tendency. Have you ever noticed that when a helicopter lifts off, it tends to drift sideways? This phenomenon, known as translating tendency, is another challenge pilots must overcome, particularly during hovering maneuvers. Translating tendency arises from the complex interaction of aerodynamic forces acting on the helicopter's fuselage and rotor system. To counteract translating tendency, pilots use a combination of cyclic and pedal inputs. By slightly tilting the rotor disc in the opposite direction of the drift, The pilot redirects some of the lift force to create a lateral thrust that counteracts the sideways movement. Simultaneously, subtle adjustments to the pedals fine-tune the tail rotor's thrust, ensuring the helicopter remains pointing in the desired direction while maintaining a steady position.